Hi, good afternoon. My name is Cecil C from SingaporeStudent.com. Today is the 4th of June 2012 and the topic I'd like to cover today for our level chemistry is about how to give name to ions. So in this lesson we are going to learn how to give name to ions, and some of the ions are easy to give name to. The first one that we are going to learn is how to give name to monoatomic ion. That means ion that is made from one atom only. And for the first part, we are going to learn how to give name to ions made from group 1 and group 2 elements only. Group 1 and group 2. For elements in group 1 and group 2, it's very easy for us to give name to the ions. In the case of group 1 and group 2, the name of the atom will be same as the name of the ion, just that you need to give different chemical formula to it. So for lithium atom, then the formula will be just Li. The name of the ion will be exactly same as the name of the atom, so we also call it lithium. And the formula will be Li plus. And it's easy also for us to know the charge, because for group 1, when it forms ion, the charge will be +1, and for group 2, the charge will be 2 plus. So we can easily tell, like this one, sodium and potassium, both of them are group 1 elements. So the formula of the ion will be Na plus and K plus. Similarly for calcium also. Calcium is we found it in group 1, yeah. So the formula will be Cs plus. In the case of magnesium, calcium and barium, the formula of the ion will be Mg2 plus, Ca2 plus and Ba2 plus. And the name of the ions will be same: sodium, potassium, magnesium, calcium, barium and calcium. And the formula of the atom is also very simple. We just copy the formula from that: sodium, Na, K, Mg, Ca, Ba and Cs. So that was quite easy. The next part of the video will be explaining how to give name to the non-metals, right? Ions made from the non-metals. Another type of monoatomic ion that we must learn today also is ions that are made from non-metals. You can tell from the name of that ions that they are made from non-metals, because they are non-metals, which means you find them on the right hand side of the periodic table. In this case, the way you give name to the ions are slightly different. Usually the name ends with IDE. So if the name of the atom is fluorine, and the formula for that is F2 because it's a diatomic molecule, so the name of the ion will be slightly different. We call it fluoride. Ends with IDE. And the chemical formula for that is of course F minus. We know that because we found it in group 7. So when they form monoatomic ions, all those halides will have a charge of -1. And it's applicable to all the other halides. For chlorine, it will be Cl2. Bromines, Br2. Iodine is I2. And the name of the ion, of course, we call it chloride, bromide, and iodide. Cl minus, Br minus, I minus. Notice that the name ends with IDE. Is not only applicable to group 7, group 6 also. For oxygen, oxygen is a diatomic ion, so diatomic molecule, sorry. So it's O2. Sulfur is a monoatomic. And the name of the ion here is, you have two ions, two types of ions made from oxygen. Either you call it oxide or peroxide. Oxide will be O2 minus, peroxide will be O minus. The ions made from sulfur, we call it sulfide. And the name of the ion is S2 minus. Phosphorus is a monoatomic ion, P. And the name of the ion is of course phosphide. Is group 5, so the most likely ion produced is P3 minus. Similarly for nitrogen, nitrogen is a diatomic, N2, and the name is nitrite. The charge is 3 minus, so the name of the ion is N3 minus. Remember, when you mention the name of the ions, it's compulsory for you to mention the charge. So you see, for for all the non-metals, when they form ions, usually it ends with IDE when they form monoatomic ions. The next part will be how to give name to ions made from transition metals on the next video. The next type of the monoatomic ion that we are going to learn today is those monoatomic ions made from transition metals, and we can also tell that it's transition metals because the position of that element in the periodic table is in the middle between metal and non-metal, between group 1, group 2, and non-metal. So in the case of transition metals, they have multiple oxidation states. Means the same element can have more than one type of ions. I can give example here, like the vanadium. You find it on the period 4, vanadium there. And vanadium, the symbol for vanadium is of course Phe. And vanadium have a lot of ions. In this case, I give the example vanadium 2 and vanadium 5. So the rule here is very simple. After the name of that element, you must put Roman numerals, and that Roman numerals indicate the charge of that ion, right? So with vanadium 2, then the charge will be 2+. With vanadium 5, charge will be 5 plus, so it's become V5 plus, right? So for all the transition metals, the name of the ion and the name of the atom will be slightly different. The name of the ion will contain Roman numerals inside the bracket. So like this, like titanium 4, the formula for that is Ti4 plus. Chromium 3 is Cr3 plus. Copper 1 is Cu plus. Copper 2 is Cu2 plus. Iron 2 is Fe2 plus. Iron 3 Fe3 plus. Silver 1. Silver is in period 5, right? Period 5, and the symbol for that is Ag, stands for argentum. So silver 1 is Ag plus, aluminium 3 is Al3 plus. Aluminium is on period 3. Lead, you find it on period 6, group 4. Lead 2 is Pb2 plus. So the name of these ions have Roman numerals, right? This is because all these transition metals have multiple oxidation states. So we need to put Roman numerals to indicate which ion we mean. The chemical formula of the atom itself is very easy, of course without a charge. So titanium is Ti, chromium is Cr, copper is Cu, iron is Fe, silver is Ag, aluminum is Al, lead is Pb. So that's how we give name to ions made from transition metals. The next video will show you the most complicated type of ions called polyatomic ions. The last type of ions that we are going to learn today is called polyatomic ions, which means the ions are made up of more than one atom. So this thing is a little bit more difficult for us to memorize because you cannot find it on the periodic table, because it's not one element, it's not one atom, it's made up of two or more atoms. So what to do? We need to memorize some of the more common polyatomic ions, and the list here that I give to you is not the complete list. There will be a lot of polyatomic ions. The one that I put here is the one that is commonly used, the one that most people know. We have a lot of ions, and see whether you can give name to it. The one that you're most likely to know is SO4 2-. I think you know. The name will be sulfate. Another type of ions that you're most likely to know also OH-. Remember what is OH-? Yeah, is hydroxide. SO3 2-. We seldom learn about SO3 2-. Is called sulfide with T. Remember that sulfide with IDE is S2- only. So SO3 2- is called sulfide. This is because you have less number of oxygen. So that's usually if you have less oxygen, it will end with ITE. If you have more oxygen, then it will end with ATE. So SO4 2- is called sulfate. So similarly, NO3 to minus, we are going to call it nitrate, and NO2 minus, we call it nitrite. For the same reason, NO2 minus have less NO2 minus have less oxygen than NO3 minus. PO4 3 minus, we call it phosphate, and PO3 3 minus, we call it phosphite. Ends with ITE. Phosphate is PO4 3 minus. CO3 to minus. I think most of you know. This one is called carbonate. CN minus. CN minus is not so common. It's called cyanide. It's a type of poison. NH4 plus is ammonium. Cr2O7 2 minus is dichromate. So remember, in quantitative analysis, you learn about tests for sulfur dioxide using potassium dichromate. So that potassium dichromate is this one. This is the dichromate ion. Similarly, MnO4 minus is also a very strong oxidizing agent. The name is permanganate. So we have 6 plus 6, we have 12 commonly used polyatomic ions. These are quite common. It's good if you can memorize all of them.